For doing polar questions, these are the equations that you need to know, which is the formula for x and y, and also dy over dx is the slope for the polar curve, and then you need to know the area of polar.
So let's just look up a polar question. This is a polar question from 2007, which means that it's question 3 and we can use calculator for this one. And first, let's look up what does the question say. And the strategy I usually use at this part is to circle out all the information I think that is important. And for this question, I'll circle the value of r and the value of theta, where the two curves have their intersect. So let's just mark out the intersects. And as you can see, there's a line for 2 pi over 3 and there's a line for 4 pi over 3. And as we can see, the right side of the two intersects are the area from the small circle. And the left part, I will use red color. Yeah, red and green. It's the area from the big circle. So, because the area change, like it's two circles area. So we need to add up their area in order to get the total shady area together. So because this question asks for the area, so we know that we need to use the formula of the polar area I mentioned before, and I'll just write it down here so you guys can see like which number I plug into each parts of the formula. Okay, so here's one thing that makes this problem kind of complex is that the area of the small circle, because it's a perfect round circle, so we don't really need to use the formula, the 1 over 2 and r squared thing. We only need to use the normal formula for the area of the small circle. But for the big circle, which is not that perfectly round and it's not really technically a circle, we need to use this formula. And this is why we plug the r for the big circle into the formula of the polar area, but not for the small circle. We also put the insects into the integral, and then we plug this equation into the calculator and we should get the result, which is 10.370. Now let's look at the second question. In the beginning, it said a particle moving with non-zero velocity, so we now know it is about a particle moving problem. And then I'll still, like as I did before, circle out the information I think that is important in this question. And for this question, we need to know what is dr over dt. And in the question, it also gave that the dr over dt equals to dr over d theta. Usually for this kind of particle moving problem, we need to know this equation, which is dr over dt equals to dr over d theta multiplied by d theta over dt. And in the normal question, I usually give you the value of d theta over dt. But since here it said dr over dt equals to dr over d theta, so we know that d theta over dt just equals to 1. And we will just need to find the value of dr over d theta to solve this problem. And what is dr over d theta? It is literally just the derivative of r, because the r value is 3 plus 2 cosine theta, and it has theta in its r equation, and we just need to take the derivative of it, and then plug theta equals to pi over 3 into the calculator, and then we should just get the answer, which is negative 1.732. However, this question is not over yet, because there's still the next half of sentences interpret your answer in the motion of the particle. So we cannot just leave the number here. We also need to say what is the motion of the particle. And since we know that our answer is negative something, then our answer is less than 0. And we know that dr over dt is less than 0, which means that the particle is moving closer to the origin because it's moving kind of backward. Okay, so let's take a look at question C. After we do question B, we should find question C is a simple one because it's similar with question B, but the only difference here is that one is dr over dt and one is dy over dt. So what is y? Remember the equation of y I mentioned before? It is y equals to r sine theta. And because this question said dy over dt just equals to dy over d theta, so for solve this question, we just need to take the derivative of y when when theta equals to pi over 3, sorry. And we just plug this equation into our calculator and plug theta equals to pi over 3, and then we should just get a value 0.5, which is larger than 0. So when it is larger than 0 and it is the value of y, it is different from part B. The particle is actually moving away from the origin, moving away from the x-axis because the y volume keeps increasing. And then we just write down the particle is moving away from x-axis. And that's the answer for this question.